Hello everyone, today I'm going to show you how to generate the hash and also how to do symmetric encryption using OpenSSL. OpenSSL is one of the most famous and widely used utility in the Linux and also Windows operating systems to do cryptographic algorithm. So today we are still using Practice Cloud Store, so you can simply purchase the hands-on cybersecurity course, and when you purchase, go to the system, you can reserve the lab for yourself. So here, let's reserve the lab for hash and symmetric encryption. It includes OpenSSL to generate hash algorithm and also to generate symmetric encryption using AES-256. Let's simply go ahead to reserve the lab for now. So once you reserve the lab, you can enter the lab immediately. And then here we have a server and we have a client as usual, but this lab we only need a server machine. So you simply just follow the lab menus to complete the lab tasks. For the better usage, you can just maybe to open this in a different window, open the menu in a different window, and then you can open the virtual machine in the screen mode, in the screen full screen mode, so that you don't need to take care of the rest of the window. So once you enter the lab, you can immediately start with the lab. Let's first try to generate the digest. You can create a file, a test file in your current directory, and then let's just use that example. This time I'm going to generate a simple string and reassign it and redirect it to the text.txt. And now you should see a text.txt here in your directory, and then you can use OpenSSL to generate a digest. Digest usually will help you to generate the hash, a cryptographic hash that allows you to verify if the file has been tampered or not. To do that, let's use OpenSSL and use the subcommand digst, stands for digest, and then followed with the algorithm. Here I'm going to use the SHA-512. That's the safest cryptographic hash algorithm at this time, and then followed with the file that you want to generate digest. And then this digest will generate out. It's going to be a string. So of course you can try different kinds of other algorithms. You can do MD5, which I already believe not to be safe, but it's still available in this OpenSSL. So this is for generating the cryptographic hash. And then next, let me show you how to generate symmetric encryption to do symmetric. And then next, let me show you how to do the symmetric encryption using AES-256. That is believed to be the safest algorithm right now. And to do that, you simply can use the command OpenSSL and encrypt that with AES-256 CBC. Right, so and then here we want to generate the ciphertext in a text document. I'm going to provide option -A, and we want to include a -sort option so that the ciphertext, every time the ciphertext generated, will be different even if I'm encrypting on the same file. As a result, the attacker, by looking at ciphertext, won't be able to derive back to the plain text. So that's why I'm putting sort here. And then next, I'm going to provide a file that's going to be encrypted. Again, here I'm going to use the text.txt, and then next gonna be the file that is receiving the ciphertext. I'm calling it test.enc, so stands for encryption. And then I can do the encrypt now. And then it asks me to type in the password. Password will be used to generate the symmetric key used to encrypt the file. And then I can type in any password I want. But you have to remember this password. Right. So once the password has been typed in, and then you can see the test.enc has been generated. I can simply print it out to see what is in there. So it's just a bunch of characters. That's the ciphertext. So you probably noticed that they have some warnings here, and they said that the key derivation algorithm is deprecated, and it is suggested to use the PDK-DF2 algorithm, and also to provide the iteration numbers as option. So this key derivation procedure is happens when the user typing the password. The password will be used to generate the key, but it seems like the default key generation algorithm no longer to be secure. So we want to do a more secure option by adding those options in there. So we can still use the same command, but here I'm going to add two options here. Firstly, I'm going to make sure I'm going to use PBK-DF2 algorithm, and I'm going to specify how much iterations I need. And then you can simply provide the iteration numbers. Here I'm going to have the iteration number to be 10,000. So basically the idea is that the same procedure of deriving the key is going to performed by 10,000 times, sort of to make it very slow for the attacker. If the attacker wants to do brute force attack, then the attacker have to repeat this procedure for all kind of different possible keys, and each procedure instead of only run one iteration of the key derivation algorithm, it needs to run 10,000 times. So that will slow the attacker's progress significantly. So here let's re-encrypt the message again. And again, you have to type in the password. Right. So then we have generate the ciphertext. Now, if we check the ciphertext, it should be test.enc. Right. So it's a new ciphertext that has been generated. Then now let's do the decryption. To do decryption, things are fairly same. The only difference is that this time the input will be encrypt, will be test.enc, and the output would be, let's give a different name. Maybe we call it decrypt or DEC. And the decryption procedure simply just reverse steps of the encryption. So I still need to use the same key derivation algorithm options and the iteration numbers. And the only difference is that I'm going to provide option -D stands for decryption. The subcommand will still be encryption. So one more information about this command is that here we are using the encryption algorithm AES-256 CBC. CBC is simply just the ways that they arrange the cipher, the block cipher encryption and decryption. So that's pretty much all we need to do, and we simply hit enter and we type the decryption password. This should be exactly the same as your encryption password. Once you type in the password, then it is believed that the decryption is successful. You can check the decryption by the decrypt text by looking at the file, that is test.dec, and then you can see that the same string has been printed out. That is the same as the original file, right? So sometimes we want to, because OpenSSL is a very nice utility to help us to do the decryption or encryption and also generate hash. We want to integrate this tool into our system so that we can do encryption automatically. Let's say that you want to create a routine every day when you finish your work, you want to encrypt all your message, sort of to protect the confidentiality of it. So you want to automate this. As you can see, that the only challenge here is that it always asks you to type in the passphrase. So is that possible that I can remove the steps of passing the passphrase? Yes, of course you can. So what you can do is that when you do encryption, and you can provide the command. You can provide the option called the dash pass, right? So dash pass simply will provide you a way to automate your password, right? So here I'm going to provide my password. I'm going to provide my password. Remember that this my password string is going to be your password. You can replace it to any password you want, right? So so that's pretty much all we need. So then we hit enter, and then it should automatically encrypt the message for us. Right, so if you take a look at the test.enc, the file has been generated. Right, so of course you can automate your decryption. So I'm going to simply just reuse the previous command, but here I'm going to provide default password. Remember that this password needs to be the same as your previous password, right? So as your previous password. So then I'm going to hit enter. Then I should decrypt my ciphertext automatically. Right. So if I check the test.dec, it's decrypted automatically. Right. So one interesting thing that you can do is that you can basically measure the time that you use to encrypt and decrypt of different files. Apparently, if the file size is larger, then the encryption time would be larger, right? So that's something that you can try. So in order to do that, you can use a command time ahead of any command you want to measure time of the command of execution. So here I'm going to provide time ahead of this decryption steps. So this actually shows me the decryption time. So you can actually try a larger file and then to observe how the time change as the decryption happens on a larger file. And sometimes you may want to measure the resource of the file, resource of the decryption or encryption steps. So what you can do is that you can use the command. You can use the application called the user bin and the time, and provide -v that will actually give you more details about your encryption or decryption. So if you hit enter, then you will see that this actually provides you a lot of information, including how much percentage that is used for this job, and also what is the page size, and also what is the maximum resident set size. Right. So all this information will basically provide you the details of the whole encryption or decryption procedure, including CPU usage, memory usage, and I/O usage. Right. So for more details, you can look up online. And I wish that you can try different files, try different size of the files, and then to observe the time and the resource usage of different files. Right. So that's pretty much for the digest and the symmetric encryption and the decryption.